Mr. Tarou, in this lesson we are going to be talking about adding and subtracting real numbers. Basically, combining numbers, not with multiplication or division, but combining numbers through addition or subtraction that have different signs. We're going to be talking about combining numbers or adding numbers that have the same sign first, and then we're going to talk about combining numbers with different signs. And I'll include some very mathy language that probably looks like what is in your textbook, and I'll use that, but I'll also try and give you some ideas of ways that you can think about doing these problems a bit more of a common sense type fashion, if you will, using number lines or thinking about making and spending money, how that comes in and out of your hands, to make this make sense as best as I can. So to add two numbers with the same sign, and this is the type of addition that students most usually feel comfortable with, or usually feel the most comfortable with, we're going to find the absolute value of each number. We're going to add those numbers, and the sum is going to keep the sign of the two numbers that you added. Now, this is steps that, again, look like what you would see in a lot of textbooks, this idea of finding the absolute value of numbers. You might take for granted some of these mathematical steps that maybe you can just do in your head very naturally, especially if you think about spending money. That's a subtraction where money's coming out of your hand, or bringing money in where it would be in addition to what you have. So, but the absolute value. Now, the absolute value of a number, that is a definition that does come up a lot in mathematics, not just doing basic arithmetic like we're talking about here. We even talk about absolute value functions in calculus, many years from probably where you're studying right now. So it's not a bad definition to talk about. The absolute value of a number is the distance that number is, the distance between a number and 0 on the number line. So what we basically see is that absolute values get rid of negatives. So the value of -5, now on a number line to the right of 0 are your positive values, and your numbers are getting larger as you go to the right, and then your numbers decrease as you go down the number line to the left. And once you pass 0, on the left all of your numbers are negative. And maybe it wouldn't have been a bad idea for me to just label all of these values that I've at least marked on the number line, and it goes in both directions forever. So this value of -5, well, -5 is, if I count this off, 1, 2, 3, 4, 5 units from 0. So the absolute value of -5 is equal to 5. And 3, my farthest right point that at least I've marked on my number line, it goes to the right forever and to the left forever, to positive infinity and negative infinity, but 3 is 1, 2, 3. Now notice I'm starting at the 3, and I'm starting to count as I move towards the 0, and I move 3 times to get from the value 3 to 0. So the absolute value of 3 is equal to positive 3. So don't think if you see a bunch of absolute value signs and the sign changing from negative to positive that that's what an absolute value symbol does. It doesn't change the sign, it tells you the distance that number is from 0. Thus, your answer is always going to be positive. Now, we can talk a lot more about absolute value functions and absolute value signs, but right now we're just talking about single numbers, and it is going to get rid of that negative sign in front of that singular number. I got a couple examples here, and I have more, I just ran out of room. So we have something here that we're probably very comfortable with doing, just simply 9 plus 3. Now, most students probably would just get this right right off the bat. They have a positive 9 and you have a positive 3, and if you count that off or just know your arithmetic, your addition, that's going to be a value of 12. Now, if you are just starting with your idea of adding and subtracting values, then maybe you need a little bit of help, say, on the number line. The addition of a number, a positive number, is a movement to the right on the number line, and ultimately here we're going to talk about negative values, and those are a movement to the left. Negative values or subtraction of a value is a movement to the left on the number line. So if I start off here at 0 and begin with my positive 9, that's 9 movements to the right because it's a positive 9. And now I'm looking on the number line at the value of 9, and then I have a plus 3. Well, that's going to move me farther to the right 3 more spaces. Well, if I count out 1, 2, 3, I'm going to be at my answer here, as we can see, of 12. So positive 9 plus 3 is equal to 12, or that's 2 movements to the right on the number line. You can also think of addition again, if you want to talk about money, that an addition is money coming in. It's more money in your pocket. So if I have $0 and somebody gives me $9, well then I have $9. If someone then gives me an additional $3, now I have a total of 12. So we have a thought of just, we have, well, in this really mathy language, absolute value. So the 9 and 3 are already positive. We go ahead and add those. We get 12. And both of these numbers are positive before taking the absolute value, if you will, even though they're already positive, so I didn't show that. And the 12 stays positive because both 9 and 3 are positive. Well, here we have -2 minus 3. Well, if you want to talk about money, if you have 0 money in your pocket and you need to spend spend $2, well, now you're going to owe somebody 2. And then if you need to spend another 3, but you still owe somebody else $2, that means you have to borrow another 3. So if I borrow 2 and borrow 3, that means I owe, a total of $5, or the answer to this is going to be -5. Or I can think of this as rewriting this -2 minus 3. I can rewrite that as -2 plus -3. And now we get into this idea of, adding. I've rewritten just -3 as a plus -3. Now, following these directions that our textbook likes to give us, find the absolute value of each number. So the absolute value of -2 plus the absolute value of -3, well, that's going to be 2 plus 3, and then our final answer is 5. But our final answer isn't really 5 because we weren't combining two numbers with like signs that were positive. We were combining two numbers with like signs that are negative. So again, it says find the absolute value of each number, add those numbers, but then the sum, and that sum is again the answer from the addition, must keep the sign of the two numbers that you added. Well, the two numbers we combined, the two numbers that we added were both negative, so this is a -5. Well, that might make sense to you and it might not. So again, we can take a look at a picture. We start off at 0, and we have -2. Well, movements to the right are positive, and movements to the left are negative. So -2 on the number line starting from 0, because I'm at the beginning of my arithmetic here, is 2 movements to the left, landing us on -2. And then the -3 or the plus -3, these are equivalent statements. That -3, that plus -3 is 3 more movements to the left because it's negative from this line, not back at 0. So 1, 2, 3. Another 3 units to the left, and look at where I'm at. I'm at -5. So we did the same problem 3 different ways, following these very mathy sounding steps about finding absolute values and adding and keeping the sign of the original two numbers, which is often what I say in class. We talked about maybe money. If you spend 2 and you spend another 3, you've spent a total of 5, or maybe if you're talking about borrowing money, you would owe a total of $5. Or visually, 2 left movements on the number line because, well, movements to the left are negative, and we combined 2 negative numbers. That was 2 movements to the left, and our answer is -5. I got another example about combining numbers with the same sign that deals with fractions. So our third example here, we have -3/4 minus 1/3. Or, if you like, we can rewrite this as -3/4 plus -1/3, and that's equivalent statements. Now, to add or subtract fractions, hopefully you remember, if you've studied them already, that you cannot add or subtract fractions unless the two denominators are the same, or you have common denominators. That's the numbers on the bottom of the fractions. So, to find common denominators, the best technique to use if you're doing them mentally in your head, or without the aid of a calculator, you can show some scratch work on some paper, is you need to find the lowest common multiple. Now, I like to do that just by saying, okay, let's take 4. Well, the multiples of 4. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, and so on and so on. Our multiples of 3, well, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, and so on. Well, as I look down these multiples here, the list of multiples, I have a common number of 12. Now, 12 is the third number in the list for the multiples of 4, so I have to take this 4, and if I want to find a common denominator, which by the way is going to be 12, this is the lowest common multiple, I need to multiply 4 by 3, and you know, I'm trying to make the fraction look different, not change its values. So I can't just multiply 3 in the denominator and that's it, because, well, that's going to change the value of the fraction. But if I multiply the numerator and denominator by 3, the top and bottom number, 3 over 3, 3 divided by 3 is 1, right? So I'm only multiplying by 1. I'm not changing the value of the fraction. When you multiply by 1, that's the identity for multiplication. You're just going to make the fraction look different. Again, not change its value. And over here, the 12 is the fourth multiple of 3, so I have to multiply by 4 in the numerator and denominator. Okay, well, I can see here that it looks like I'm just taking this denominator of 3 and multiplying it to the top and bottom of the first fraction, and this denominator of 4 and multiplying it to the top and bottom of the second fraction. You can actually do that. Every time you find a common denominator, you can just take the two denominators and sort of flop them over and, of course, multiply the top and bottom by those values. That's not necessarily going to give you the lowest common multiple, which is nice if you're, very nice if you're having to do the work without the aid of a calculator. So while it looks like I'm just swapping here, I'm not doing that. That's just happened to be the way this one particular problem came out. You can take those and swap them, but that can make the numbers unnecessarily big. If you're doing these by hand without a calculator, that can be a problem. So we have 3 times negative 3 is negative 9 over 12, and negative 1 times 4 is negative 4. Again, over 12. Now, once you find a common denominator, you're done with the denominator. You're just going to copy it over. So as I add these fractions, the denominator is 12. I've found the common denominator. I'm done with it. I'm not going to, I'm not going to add 12 and 12 and get 24. That'd give me the wrong answer. And I just work with the numerators. I just work with the numbers on top. Now you can see I have a negative 9 plus a negative 4. So this is very similar to the second example I just erased. I'm combining two numbers. I'm adding two numbers that are both negative. And, I can talk about finding the absolute value when it's 9 and 4, and we can add those and get 13 and keep the sign. And our answer I just said, it's going to be negative 13. Or you can think of that movement on the number line, left 9 spaces, left 4 more spaces, and if you count out the 9 to the left and another 4 to the left, you're going to end up at negative 13, and that is the answer. And I'm going to leave this, this fraction with the numerator larger than the denominator. That's called an improper fraction, and I'm going to go ahead and leave it that way. So that is the end of our third example of adding numbers with the same sign. What happens if they have different signs? To add numbers with different signs. We might think of that as subtraction. Find the absolute value of each number, subtract the absolute values of those numbers. The sum, except the sum is the answer from when you're adding two numbers, and we are given rules for, I'm giving you rules for adding numbers with different signs, but yet step 2 says subtract, so I kind of prefer to just say the difference. That's the answer you get from subtracting. It has the same sign as the number, the added with the greater absolute value. Now, I'll even sort of verbally, I tell my students to follow these steps when they combine numbers with different signs when they're struggling in high school with signs, maybe if they still are. And I kind of abbreviate this language, but I say the same thing. I don't always say absolute value, but you'll see, I'll explain what I mean here in a second. We have two examples. I'm not going to do any fractions with this one. We have negative 5 plus 7. Well, if you're following these directions to a T, you're going to find the absolute value of each number. So the absolute value of negative 5 is equal to 5, and the absolute value of 7 is equal to 7. And we're supposed to subtract these absolute values. Okay, so 7 minus 5 is equal to 2. Well, is the answer 2 or is it negative 2? That's always a question you have to ask when combining real numbers with different signs. Well, it says down here the sum, which again I prefer to say difference because I just subtracted. And I have a plus sign here, but I'm combining a positive 7 with a negative 5. At any rate, has the same sign as the number, the added in, with the greater absolute value. Well, I'll tell you what I'll say in class. I'll say, well, you're combining values of -5 and 7. They have different signs, so subtract them, and the students will do 7 minus 5. And then I kind of sort of fib a little bit, and I say, well, what's the bigger number? And I'll sort of say that in the sense that I want the students to ignore the signs and just go, that's actually what the absolute value, the absolute value function does, is it sort of lets us ignore those signs for a minute and just look at the positive values and go, oh, 7 is bigger. Good, well 7 is bigger, it's positive, so our answer is just going to be positive 2 like I have written here. Now again, you can think of this as money coming in and out. If you have 7 and you spend 5, you have a positive $2 left over. Or maybe if you owed somebody $5 with a negative value and someone gave you 7 or you earned 7, that would still leave you 2 left over after you paid that person back. Or visually, on a number line, we've got, again, starting with our value of 0, the center of our number line, if you will, we're having -5 and a positive 7. Well, negative numbers are to the left, positive numbers to the right, so move to the left 5 spaces. So 1, 2, 3, 4, 5. And we're right currently at this point at -5 on the number line, and then +7 is to move to the right 7 spaces. So 1, 2, 3, 4, 5, 6, 7. So that's -5 or 5 movements to the left, positive 7 or 7 movements to the right. Again, starting from 0, the center of the number line, and we end up with 2, which is our answer. Here we have 2 minus 6. You might want to rewrite that if you're comfortable as 2 plus a -6. Those are equivalent statements. And we can, again, find the absolute values, subtract, and keep the sign of the greater absolute value. So here it would be the absolute value of 2 is equal to 2, and the absolute value of -6 is equal to positive 6. Subtract those numbers, and I'm going to subtract in a way that I know I'm going to give you, sort of a temporarily positive answer. So 6 minus 2 is equal to 4. So that is find the absolute value of each number, subtract them, and then keep the answer has the same sign as the number with the greater absolute value, the perfect way to say it. Well, the number with the greater absolute value was -6. The -6 gave us the absolute value of 6, and the absolute value of 6, the answer is 6, and 6 is bigger than 2, and so the number that gave us that bigger value is was the -6, so our final answer is going to be negative. And that's the perfect mathy way to say it. I would just go, hey, you got 2 minus 6, a positive 2 and a -6. You're combining a positive number and a negative number with addition or subtraction, however you want to think of it. Subtract them, okay? 6 minus 2 is 4. Well, what's the bigger number? And again, ignoring the fact that really, a positive number is always going to be bigger than a negative number, but I want you to ignore that sign, right? Well, 6 is bigger than 2. 6 is bigger than 2. And the 6 is, well, came from a -6, and so our answer is -4. Or, if you have $2 and you want to spend 6, then you're going to owe somebody $4 with that negative value. Or visually on the number line, one more time, we have, starting from 0, a positive 2, that's 2 movements to the right. And then from that place on the number line you are currently, -6 or a plus -6 is 6 movements to the left. So 1, 2, 3, 4, 5, 6 lands me at -4, which is my answer. Well, that's really how you combine numbers with the same sign and different signs, but I have a couple of definitions to give you before we call it a day and hopefully help you do your homework. Opposite numbers. Two numbers whose sum is 0. They are in the same direction from, the same distance from 0, but in opposite directions. So our example is 5 and -5. Well, they're supposed to add to 0. The sum is supposed to be 0. So that means that 5 plus -5 is equal to 0. Anytime you add numbers where one is positive and you have the same number but the other one is negative or different signs, you're going to get a sum of 0. I've drawn a number line. We have 0, we have -5, we have +5, and just to recap or review that idea of absolute values, -5 is 1, 2, 3, 4, 5 units away from 0, and +5 is, again, 5 units away from 0. So they're the same distance away from the 0 on the number line. Thus, when you subtract them, if you will, 5 plus -5 is the same as subtraction. 5 minus 5 is equal to 0. Voila! The inverse property of addition, which I kind of just hinted to there. For every real number, a, there is an additive inverse, negative a, or actually I shouldn't say negative a, but the opposite of a, because I don't know what a is. Maybe a is -4. So then the -4, the opposite of -4 is +4. And such that a plus the opposite of a is equal to the opposite of a plus a is equal to 0. Or, that's what we have here. 5 plus the -5 is equal to 0. This is just saying the same thing in general terms. And I've already alluded to this a little bit, or hinted to it in my notes so far. A minus b is the same as a plus the negative b. So to subtract real numbers, it's said that you can add the opposite. So I'm going to do some examples before I close the video using this idea. Now actually I teach Algebra 1, Geometry, Algebra 2, I teach calculus, and as you move up through algebra you work with a lot of signs. So actually we show this when you first start learning about how to add and add numbers with the same and different signs, but honestly I actually try and move my students more towards this idea of just stop writing the plus negative and just write minus, okay? If I cover that up, you would say negative b. If I put the a out front, you would say a minus b. So for right now, your teacher could very well be using this idea of, encouraging you to say, add the opposite or add that negative b. But if you run into one of my classes as you move up in the ranks of mathematics, you want to get more comfortable with just using the single sign as well of a minus b. -4 minus 7. Well, again, if you want to subtract, you can rewrite that as adding by the opposite of that number. So if it's 4 minus 7, I can rewrite that as -4, change that subtraction to addition, and add by the opposite. So if I want to subtract by 7, I want to add by the opposite of 7, and so it'd be 4 plus -7. And that goes back to our first rule, adding or combining numbers with the same sign. We want to add those numbers and keep the sign. So 4 plus 7 is equal to 11, and both of these numbers are negative, so the answer is -11. Or again, move 4 on the number line and then move another 7 units to the left on the number line, and you'll end up with -11. Here we have -2 minus a -5. Well, I'm actually show you two ways of thinking about this. The second way is going to be assuming or kind of giving you a hint as to how you multiply with signs. But for now, keeping with the idea that we're adding, if that previous page said that if you want to subtract by a number, you want to add by the opposite of that number. So if I want to write, -2, and I want to rewrite this so there's not a minus sign. So if I want to change subtraction to addition, then I want to add by the opposite of that value. Well, the opposite of -5 is +5. So 2 minus a -5 is the same as -2. Did I miss that negative sign there? -2, changing the subtraction to addition, and add by the opposite of that value. Well, the opposite of -5 is +5. And -2 plus 5, well, let's go back to the number line. I like that better, really, honestly. You have 0, you move 2 units to the left, and then 5 units to the right, and you're going to end up at a +3, or simply 5 minus 2 is equal to 3. And 5 is the larger number, so the final answer is 3. Now, another way of thinking about this is to go, all right, well, we have -2 minus, and then slip a 1 in between the minus sign and the parentheses. And then when you start learning about how do you multiply with signs, one of the rules you're going to learn is that when you multiply two negative numbers, you get a positive answer. So negative 2, because you have to multiply before you add or subtract. So negative 1 times negative 5, when you multiply two negatives, you get a positive answer. And you can see I just wrote the same thing again. Negative 2 plus 5 is going to be equal to 3. Now for our last example, we have an expression. We have negative 8 plus b minus c. Now again, I said negative a, and then here I said minus c. If I covered this up, I would read that as negative c. With something in front, I'm going to say minus. I use those, you have a negative key and a minus key on your calculator, and they're not really technically the same thing, but I use them interchange them in classes I'm teaching. So what I want to do is I want to look at this expression. I've got some numbers to plug in, and I'm going to just write negative a plus b minus c. I'm not even looking at what I'm plugging in, because all a variable is an open space to put in a number. It represents a value which we don't know what that value is. I don't know if a is positive or negative, but I see that it's the opposite a, or the negative a, so negative empty space plus empty space minus that empty space for c. And what are we plugging in? Well, we're plugging in a is equal to 5, okay, b is equal to negative 2, and c is negative 3. Now, the reason why, again, I write out my parentheses where my variables are, without even thinking about what I'm plugging in, is because some students will think, oh, there's a minus and there's a minus, so I can just write minus 3. That's not going to be right. The expression has a negative sign or a minus sign, and the number that's getting plugged in is bringing its own negative sign in there, and if you don't see those side by side, one from the expression, one from the number you're plugging in, you're not going to get the right answer. And hopefully those empty parentheses encourage that behavior of remembering all the signs that we need to worry about. Well, we have negative 5, and you can write plus negative 2 or minus 2, whatever you like. I'm going to write plus negative. And we're subtracting by a negative number, so I can change that subtraction to addition and add by the opposite number. Or I can think of negative times negative as positive. Either way, it's plus 3. Now I have negative 5 plus negative 2. I'm combining numbers with the same sign, so I want to add those numbers and keep the sign. So that's going to be negative 7 plus 3. And now I'm combining numbers with different signs, so I want to subtract them. 7 minus 3 is equal to 4. Really, I should be saying, thinking about the absolute values, but, the absolute value of 3 is 3, the absolute value of negative 7 is 7, the bigger absolute value is the 7, so our larger value, if you will, is negative. So, well, see, that's not really right, even though that's what I always say in class. The largest absolute value is 7. And that came from a negative 7, so our final answer is negative 4. And if I lost you on that last little piece there, again, go back to the number line. You're at 0, you go left 7, and then you go back 3, and you're at negative 4 because you're to the left of 0. So, I'm Mr. True. Bam! Gotta do your homework.